When lost deep in the dark woods, relying on a small piece of metal to find your way home requires a lot of trust. You watch the needle spin, trusting that it will inevitably lock onto N and point you safely toward the north. That trust is built on a basic rule of elementary physics. Identical poles violently push away from each other, but when you flip one around, the opposite poles immediately snap together and lock in place. Like repels like, opposites attract. Our survival in the wilderness depends entirely on this unbreakable law. But apply that law directly to your compass. The red tip of that needle is physically a distinct magnetic north pole, and when it settles, it is being pulled straight towards its destination, the Earth's geographical North Pole. Since that needle is a North Pole and it's pointing at the North Pole, physics dictates these two should repel each other. Based on the laws we just established, the compass should be physically incapable of pointing north, unless our understanding of the planet is wrong. To solve this, we have to scale up from the compass in your hand to the entire planet. Looking at this X-ray view, the planet operates as a colossal bar magnet buried inside. But notice the orientation. This internal magnet is completely upside down. The top of the globe, the geographical North Pole, is actually the planet's true magnetic South Pole. When your compass swings north, its red North Pole is simply seeking its true opposite, the massive magnetic South Pole buried under the Arctic ice. The compass isn't breaking any rules. It is flawlessly executing the law of attraction on a planetary scale. Generating a magnetic field of this magnitude requires a massive internal engine. Thousands of miles underground lies the Earth's outer core. It is an ocean of superheated liquid iron, churning under immense pressure. This moving metal creates an engine that physicists call the geodynamo effect. This cross-section shows the process in action. As the Earth completes its daily rotation, it spins that liquid iron. The movement generates massive electrical currents, which in turn produce magnetic field lines that cascade out into space. That tiny sliver of metal guiding the lost hiker is physically locked into a churning planetary engine operating thousands of miles beneath their boots. If the top of the world is magnetically south, you might wonder why humanity labeled it north to begin with. Centuries before anyone understood geophysics, early navigators and cartographers drafting maps like this one named the poles based purely on the physical axis the Earth spins on. They needed a reliable grid for human navigation, relying on the sun and the stars, entirely separate from the invisible magnetic forces acting below the crust. They accurately mapped the terrain, but accidentally drafted a linguistic contradiction. They left us with terminology that perfectly masks the true physics of the planet. This magnetic field acts as the primary defense system for our entire planet. Periodically, the sun violently erupts, hurling a wave of highly charged, deadly radiation directly across the vacuum of space. Here, these magnetic lines form an invisible planetary shield, catching the incoming solar wind and bending it harmlessly away. Without this magnetic South Pole anchored at the top, the radiation would bombard the surface and strip our atmosphere entirely away. That compass needle is a real-time monitor for the invisible shield keeping us alive, operating strictly on the physical law that opposites attract.